those of you that just got in here, happy Thursday. Happy Thursday. One more day till Friday. One more day till Friday. Then a couple more weeks till spring break. Couple more weeks till spring break. I think next week, okay, I think we have 3 weeks, right? Next week is the 8th. Monday's the 8th. And then the next week, the Monday's the 15th. Then the next week, the Monday's the 22nd. That week, Monday the 22nd, we go to school Monday through Thursday. And then that Friday we have off. And then we have the entire next week off. So spring break is coming. Yes, there is light at the end of the tunnel. And yes, you guys are being tested this year. So when you get back from spring break, it'll be April. And I think about 2 or 3 weeks after that, you'll begin your state testing. And it's going to be very similar to what you did yesterday with your SSID and logging in. And then, but on the camera, when you do the state testing, the camera is going to automatically be turned on. You will not have an option to say yes or no like you did yesterday. Okay, just a heads up for you juniors. If you're not a junior, then this does pertain to you. All right, so what did we get? So for the third one, what's the degree of that polynomial? Anybody? What's the degree of that polynomial, the third one? I'll number them. You want me to number them? Okay. There's 1, 2, 3, 4, 5, 6. So what's the degree for number 3? Hello, is my microphone working? Hello, is this thing on? 31. That degree, remember the degree is just what the highest exponent is, right? So if we look at number 3, the highest exponent is 2. So it's a second degree polynomial. And what's the leading coefficient? Right, 31 is the constant. 31 is the constant. It's okay. You got a wrong answer, but that's okay because that's your constant, but it's not your degree. The degree is the highest. Think of the exponents as your temperature, right? So what's the highest temperature that you see there? 2. That's your degree. And then the leading coefficient, that just means the coefficient that leads all of them, that's in the front, is 12. That's it. Okay, so that's all. I just want you to be able to identify the degree of your polynomial and the leading coefficient. All right, number 4. What's the degree of this polynomial? Three. Exactly. It's a third degree polynomial. Right? Remember, that's a cubic. Remember, second degree polynomial is a quadratic. Third degree polynomial is a cubic. Fourth degree is a quartic, which we really don't use. It's just a fourth degree polynomial. And a fifth degree is quintic, but we really don't use that word. And what's the leading coefficient for number 4? What's that leading coefficient? What's that number in front of the x cubed? I don't see a number, mister. Of course not. It's a -1. Very good. All right, number 5, what's the degree? Hey, mister, I'm noticing a pattern. That's a fourth degree polynomial. It's just going by 1. That's fine. What's the leading coefficient? Very good, -3. And lastly, what's the degree of number 6? It's a fifth degree polynomial. Very good. And the leading coefficient is, of course, that coefficient that leads. Once you have it in order, it's just that coefficient that's in the beginning. It's a 9. That's it. That's all I want you to do. Tell me the degree. Tell me the leading coefficient. Can you identify them? All right. Are we all good? Can you guys all identify degrees and leading coefficients if I ask you for it? If you're not, put a thumbs down in the chat or in the Zoom. I need some participation from you guys. Like when I ask you a question, just you have those reactions. Give me a thumbs up, a thumbs down. Someone puts that little party favor thingy sometimes. Or you can say yes in the chat. All right. But I mean, if you're like, what's going on here? I'm lost. Especially if you haven't been here in weeks. There's somebody in here that shows up once a month. Welcome. Okay. So if we're good, we're good. So now I want to talk about parent functions. All right. So parent functions, these are your basic functions. Okay. When we look at we look here, right? We have 0 degree polynomial, First degree, second degree, third degree, fourth degree, fifth degree. Those graphs look different. When I graph these, they look different. You should have an idea of what these graphs look like. Yes, they can get crazy. Yes, if you look at this fifth degree polynomial, it can get crazy because you have all this other stuff following. But all of this other stuff is just extra. All this other stuff is extra, right? All this other stuff is extra. When I talk about the parent function, I'm talking about the function that doesn't have all this extra stuff, right? That doesn't have all this extra. It just has the variable with the highest exponent. Okay? So let's look at this. So first kind of parent function is a constant function. Constant function means I have a function, f of x, and it equals some number, some constant, like 5 or 3 or 4. Right? This is a 0 degree polynomial, right? Right? And when I graph that, what does it look like? Yes, it's just a horizontal line. Right? Basically, this is the kind of equation that looks like this. Y equals 7, y equals 3, y equals 10. Those are the kind of equations that it looks like, right? Y equals -3 equals -2, something like that. So whatever number that is, that's where the horizontal line goes through. Because remember, f of x, we talked about this yesterday, f of x means output. F of x means your y, right? So f of x just means a function, you do something to an input called x. Okay, and that output's just y. So you'll see y equals 7, y equals 3, y equals 10. You see there's no x, there's no variable, so that's 0 degree polynomial. It's just a horizontal line. Okay, so now let's go to a first degree polynomial. Right? That means I have x to the first power. What does that look like? Well, look, f of x equals x. Right? X to the first power. That's your basic. That's your basic. In other words, it's just y equals x. That's the equation, right? Because f of x means y. F of x just means function of x. And so what does that basic parent function look like, right? There's no whistles, there's no bells, there's no other numbers around it. It's just f of x equals x or y equals x. Does anyone know what it looks like? Well, it is linear. First degree polynomials are linear, right? And the basic one you know is y equals mx plus b, but this is the most basic. This is the parent function. Y equals x. F of x equals x. Does anyone know what that graph looks like? Hello? This thing on? Anybody? No. So what does y equals x mean? Think about it. If I were to make ordered pairs, what does that mean? Think about it. Y equals x means my points are 1, 1, 2, 2, 3, 3, because y and x are the same. The input and the output are the same. This is right. Remember, that's your input. This is your output. So if my output equals the same as my input, that just means y equals x. That means my points are 1, 1, 2, 2, 3, 3, 4, 4, 0, 0, -1, -1, -2, -2, right? That's exactly what that means. So if I'm going to do that, it's just a basic diagonal line like this. That's your basic parent function, basic parent linear function. It's your basic parent linear function. It's a line. Y equals x. F of x equals x. Is everyone good on that one? Give me a thumbs down if you're confused. We're just looking at the basic functions. We looked at a constant function. We looked at a linear function. That's first degree. Now we're going to look at a quadratic, which is a second degree polynomial, meaning I have an x squared, right? Second degree means I have x squared. And so what's our basic quadratic function? F of x equals x squared. There's nothing added to it, nothing multiplied to it. It's just f of x equals x squared. It's just your basic quadratic function, and it looks like this. Right? My vertex is at the origin. It's my basic function. It's facing up because it's positive. And that's my basic parent function for a second degree polynomial, which is called a quadratic. And then lastly, our third one is called a cubic. Can anyone guess what a cubic is? If this is a 0 degree polynomial, this is a 1 degree polynomial, it's linear. This is a 2 degree polynomial, quadratic. Yes, I am recording this. I am recording this. So cubic would be what kind of degree polynomial? Third degree. So this is a third degree polynomial. And so what does it look like? Well, it's f of x, a function of x, equals x to the third power. And does anyone know what that looks like? Well, a cubic, its basic shape goes like this. It's going to hit, and this is what I told you before, this is like a fundamental theorem of algebra. The highest exponent is going to be how many times your graph hits the x-axis, up to how many times it hits the x-axis. Okay, so when you see a third power polynomial, you know it's going to curve, hit 1, 2, 3. Okay, so that's something you should know. The degree of the polynomial is going to tell you how many times it potentially can hit the x-axis. Now, it may dip down and not hit it, but it's potentially hit it. Okay, so this basic function looks like this. Okay. But mister, you said it was supposed to touch it 3 times. It's only touching it once at 0, 0. Yes, because this is your basic function. The more numbers you put, the more curvier it'll get. And the more curvier it gets, the more curvier it looks like this when you add numbers to it and stuff. But your basic function, f of x equals x cubed, or y equals x cubed, right? There's another way to look at this is y equals x cubed, is you just have all 3 points hitting at 0, 0. That's called the multiplicity. We'll talk about that later. But that's your basic parent function. So somebody in the chat, so I'm going to let you copy these. I'm going to have this out like this. I'll zoom in as much as possible because I know some of you say it's blurry. But again, and as somebody asked in the chat, Mister, are you recording this? Yes, I am recording this. It will be on the YouTube channel. And again, if you ever go back and watch these videos, the links are in Schoology. You go to Schoology, the link will be there. There's a link in there for yesterday's lesson. Please hit that like button and subscribe. That helps with the algorithm, helps me try to get to 1,000. We're almost to 400 subs. So someone said, Mister, things are going on in my house right now. Are you recording this? Yes, I'm always recording it. You can go watch later and fast forward. You don't have to watch the whole thing. Just go to the part where you need. All right. Any questions on this? Any questions on this? These are just your basic, what are called parent functions, right? You're going to need to know your parent functions because we're going to show, well, I'm going to show you. Should I zoom in? I'll zoom in on each one individually because, yeah. So there's a constant. I'll keep it up for 30 seconds. And then I'll move to the next one. I'll move to the next one. I'll move to the next one. So these are your basic parent functions. I'm going to show you later what you do to functions when you add or you multiply, how it affects the graph, how it affects your parent function. So if you know your basic shape of your function and then you see what's happening to the function, then you'll be able to move things around, right? It's basically transformations, what you did in geometry. I'm going to be talking about that. So you need to know your basic parent function. So that's constant. Here's linear. I'll give you a minute to copy linear. Then I'll go to the other two in a minute. And so you need to know your parent functions. So when we look at what's happening to the functions, am I adding a number? Am I multiplying a number? Where am I adding a number? Am I adding it in parentheses with the x, or am I adding it outside to the whole function? How does that affect the shape of the graph? So if you're going to figure out how it affects the shape of the graph, you need to know what the basic function looks like. Okay, so that's linear, and then second power, second degree, is a quadratic, and we've done these. We worked on these extensively in the first semester and the beginning of the second. These are quadratics. And then lastly, cubics to the third power. And as I said, the power, the degree of your polynomial usually tells you potentially how many times your graph is going to hit the x-axis. That tells you the shape. It's like if it's third degree, so it's going to hit it once, twice, 3 times. Now, the basic function here is kind of stretched out, so all three curves are basically right there. But the more you put numbers here, the more you add and subtract and multiply and put a bunch of different things here, the curvier it's going to get. And then you'll see it. You'll see it hit it 3 times. Okay. Now let's go to the next page. We have quartic and quintic. Okay. Quartic, again, we talked about that before. That's not a word we usually use. It's just we usually say a 4th degree polynomial. It's a 4th degree polynomial. It's going to look familiar. Okay, it's going to look familiar. Now, 4th degree, you're going to think, oh, 4th degree, so it's going to look like this. 1, 2, 3, 4. And potentially, yes, that's an f of x equals x to the 4th power. But when you have no numbers or anything, it kind of puts it at its basic form, and its basic form does not look like, it should potentially look like a w, but in its basic form, y equals x to the 4th, you're going to see this, a kind of thinner parabola. Yes, it looks like a parabola, and you're like, wait, that doesn't look like a 4th. Well, because it's in its basic form, there's no other numbers here, all the curves that you would see, 1, 2, 3, 4, right? All those curves that you would see are kind of stretched into just that one right there. It has a multiplicity, which we'll talk about later. But yes, it's a 4th power, so it potentially should look like this, right? But it's just a thinner version of a quadratic. But when you do have bigger 4th power polynomials, 4th degree polynomials with different numbers and stuff, you will see hitting it 4 times. And so the quintic kind of does the same thing. This is a 5th degree polynomial. Wow, I can't. That's very sloppy. Polynomial. There you go. That means f of x equals x to the 5th power. And potentially, again, you would imagine, okay, Mr. x to the 5th means I go like this, 1, 2, 3, 4, 5, which you would be correct. Potentially, that's what it should look like. It should hit it 5 times. But since this is in its basic form, it kind of like stretches out and doesn't do all these big curves and turns because there's no numbers there. It's in its basic form, which makes it look like a different graph, but it's a lot thinner. So it looks like this. Yes, that looks like a cube. You're going to say, Mister, that looks like a cubic. Yes, but you see how it's thinner because it's growing faster? And this area right here is holding 5 solutions because it's stretched out. And I know that's a little confusing. Like, wait, what are you talking about? Yes, 5th power, it should look like this. 1, 2, 3, 4, 5. But all of these curves happen because of the numbers I add and I multiply and I do that, the complexity of it, right? The more complexity I add to this basic function, the more the curves are going to come out. Does that make sense? Because I only have basic, all the curves are kind of like stuck in here. The more complexity I add, the more you'll see these curves pop out. Okay, same thing here. This looks like it only hits it once, right? And it does, but as I add more complexity to this, it'll be like this, 1, 2, 3, 4. Does that make sense? Give me a thumbs up or a yes. Okay, yeah. So it looks like these look like quadratic and cubic, but they aren't. But these are the basic shapes. When we add more complexity, you'll see the curves accentuated. All right. Everyone good. Everyone good on these, okay. All right, so now we're going to talk about end behavior. End behavior. What does that mean? So the next thing on our notes says end behavior patterns. What does that mean? So before we even go into this, because some of you are looking at these and going, okay, what the heck is this? What the heck is this? Okay, before we say it like this is the nerdy way of saying something. End behavior patterns. The end behavior is looking at each end of the graph. Okay? So a lot of you were telling me yesterday, you know how at the ends of the graphs you saw those arrows? You were telling me yesterday, what do those arrows mean, or why does it go on forever? So let's talk about that. So let's talk about end behavior instead of going into that, into this complexity, because look at that. Some of you are like, what? What are you talking about? Okay. Do you see the ends? So when I'm talking about, like, imagine this is a piece of spaghetti, right? And when I say the ends, I'm talking about this and this, the end, the farthest left and the farthest right of the graph. Okay. So when I say the end, I'm talking about the farthest left and farthest right of the graph. Right? So we're basically saying, where's our graph coming from? So if we're reading this from left to right, where is our graph coming from? Is it coming from the bottom, or is it coming from the top? And where is it going to? Is it going to the top, or is it going to the bottom? Or is it going constant? Or is it approaching something? Okay. So we're just describing. So can anyone in the chat describe what's happening on the, we'll call this the right end. This is the right end. And this is the left end. Can you, in words, I'm going to give you a couple minutes, in words, tell me what's happening with the right end and the left end. Okay, I'll give you a couple minutes to type something up. Just give me a description. And if you're wrong, guess what? It's okay. It's okay. Just tell me what, tell me what a description of what's happening on the left side and what's happening on the right side. So I'll give you a couple minutes to do that.